if I talk about homogeneous mixture, so homogeneous mixture are those mixture in which solute, or let's say the particles gets uniformly distributed, and the moment particle gets uniformly distributed, you will not be able to see the particles with your naked eyes. But if you take the example of milk, right? So the moment you're taking milk, I said you in the last class, it is an example of colloids, right? And can you tell me colloids are what? Is it going to be homogeneous or is it going to be heterogeneous? What is going to be your take? Perfect. It is going to be heterogeneous, right? Now my second question is that if it is heterogeneous, you will be able to see the particles of milk. So are you able to see the particles of milk with your naked eyes? What is going to be answer? No. The answer is no. Why? If it is heterogeneous, so why you're not able to see the particles with your naked eyes? So if the mixture is going to be heterogeneous, we will be able to see the particles with your naked eyes. I told you in the class, but I added one more term in that, and that was what? If it is heterogeneous, you may or may not be able to see the particles with your naked eyes. So it is not always mandatory that if you're having a mixture as heterogeneous, you will be always be able to see the particles with your naked eyes. This is not 100% true. So there might be a case in which you won't be able to see the particles with your naked eyes, and that case is the case with that of milk, right? So milk, if you talk about milk is a colloid, right? And if you talk about colloids, so it appears to be homogeneous, but if you talk about the reality of that, it is not homogeneous, right? So if you look at carefully, you'll not be able to see the particles of milk, right? So you'll think that, yeah, if I'm not able to see the particles of milk, it might be homogeneous, right? But actually milk is not an example of homogeneous mixture. See, although you're not able to see the particles of milk with your naked eyes, but if you talk about another effect that we discussed in the last class, that was Tyndall effect, right? So this Tyndall effect, because of this Tyndall effect, milk is categorized as heterogeneous mixture, right? Because homogeneous mixture do not show Tyndall effect. This is 100% true, right? So which mixture shows Tyndall effect? The answer is going to be heterogeneous mixture, right? And if milk is showing this phenomena of Tyndall effect, it means that milk is going to be categorized as heterogeneous mixture. Although if you see with your naked eyes, you will notice that it appears to be homogeneous, but actually it is not homogeneous, right? And this is what is known as Tyndall effect. Tyndall effect, you already know. If you pass a beam of light through the glass, if you take a glass of water, right? Now, what you're going to do, you are going to pass a beam of light, right? And if you observe carefully in the glass which is having milk, you will observe that the scattering of light will happen, right? Now, why the light is being scattered in the glass in which you have taken the milk? It is because of the particles of milk, right? So these particles of milk are acting as a hurdle for the light to pass on, right? Now, if the particles of milk are going to be acting as a hurdle, it means that the particles of milk will not allow light to pass through as it was passing in case of homogeneous mixture, right? And the moment scattering of light will happen, you will be able to see the path of light. And the moment you are able to see the path of light, it means that Tyndall effect is being shown by milk, right? This is what is Tyndall effect, right? So milk shows Tyndall effect. And if milk is showing Tyndall effect, it means that milk is not going to be homogeneous mixture. Rather, it is going to be heterogeneous mixture. And colloids are nothing, but colloids are a type of heterogeneous mixture, right? I hope the concept is clear. Now, I told you in the beginning, if you talk about homogeneous mixture, so it is the size of the particle which decides whether the light is going to be passing through that mixture or not, right? If I talk about homogeneous mixture, I told you in the last class that the particle size is less than 1 nanometer. And you can imagine how small, how micro the particle size is, because it is even less than 1 nanometer. And 1 nanometer is very, 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 very small unit, right? Now, if I talk about colloids, so the particle size of colloids varies between 1 nanometer to what I told you? It is greater than 1 nanometer, but it is going to be less than 1000 nanometer, right? This is what is the particle size of colloids. Now, if the particle size of colloids is greater than that of the particle size of homogeneous mixture, obviously, Tyndall effect is going to be shown because the particle size is more. And if the particle size will be more, it will be acting as a hurdle for the light to pass on, right? And the moment it is acting as a hurdle for light to pass on, so you will see the path of light, right? And the moment you are able to see the path of light, it means that it is showing Tyndall effect. I hope it is clear. Now, coming to another type of heterogeneous mixture, that is going to be what? That is going to be suspension. That we are going to study in this class, right? We are going to discuss about this concept of suspension in this class itself. Up to here, everything is clear. Tyndall effect is clear. Colloids is clear. right? Heterogeneous mixture is clear and homogeneous mixture is clear, and the properties of all these are clear, right? Now we will be talking about the types of colloids, and then we will be discussing. Yeah, any question?